for 7 years in September, a couple years on the engineering side, and about 4.5 years doing partner engineering, which means that I link up with the biggest, latest, and greatest companies to help them implement different Google products as so far as they're interested. So um, today I wanted to talk to you about our built-in AI project. Essentially, it allows you to get AI features on your website through plain old JavaScript without any server calls, without any of the extra fluff that's required normally to set this up within buckets or other aspects like that. Now, I'll get into the details of this later, but mind you, this is a much smaller model. And so it's got very specific capabilities that it's able to handle, but I think ones that folks would be quite interested in using for their websites. So I want to talk about the mission of our team quickly, which is really just make Chrome and the web smarter for all users and developers. As we know, Chrome is a browser, and when we're talking about the web, we're talking about the expansion of all the things that compromise the internet. And when we say let's make it smarter, it's really about how we can help these users achieve their goals more efficiently. And in this case, users is really all of you, the developers, and of any skill level. We don't want to make it such that there's a barrier to entry because you didn't study ML or you might not know like the underpinnings of how to train a model. Like that's what we want to be able to enable you guys to do quickly, easily, so that you can just plug and play. And then lastly, for all the users, we're really making this optimal for everyone to be able to access. So when you build something great, folks come to your site, they have the latest and greatest technology and they're able to get the most out of that. Now, there's a lot of acronyms that you'll hear in this space, especially recently. Obviously, AI is the biggest buzzword of 2020. The next one is probably ML, LLMs, Gen AI. Uh, for the purposes of this talk, they're all one and the same to us. And what I really want you to understand in this moment is that they're powered by models, and these models vastly differ in capabilities depending on how big it is, resource requirements, its training process, all these things. And so what we really want to focus on today is like that specific left side of this slide here, which is the lightweight models. When we say there are massive models, we quite literally mean that. There are models that are thousands of gigabytes, if not like going on terabytes of process compute that is needed to make them effective. And that's typically what you'll find on the server side. What we're talking about today is the teeny and tiniest models. This one in particular is Gemini Nano and Chrome. And Gemini Nano also offers some really great things that we think might be useful to the broader web ecosystem. And so what we tried to do here is let's see if we can put these lightweight models on the client side such that you get some tangible benefits from having it be there. The first is you get to access it within the browser. There's actually something you could do right now if you got a chance to check out the pre-work and you enabled some of those flags. If you went into your console, you could actually say AI.language model or window.language model, excuse me, and it will be available to you as a return object. And so what we're trying to do here is not only bring this to the client side, two other things that I think we're really doing that's really useful. First, we're making this perform a lot better and faster, not from the essence of it can do things that server-side models can't do, but rather it's really quick because it sits much closer to the user's machine. And so it's using your GPU, your CPU in order to perform its computations, and you don't have to wait for the internet to give you a response. That being the second part of this, which is really awesome. If you don't have internet, you still have AI capabilities available to you because it lives on your machine. And it's 100% private in that regard as well, because it's not making any server calls while it's doing its computations. And then lastly, which I think is probably the most important thing, especially for smaller developer communities, is it's super cost efficient. There actually is no cost. You can run as many queries as you like until your computer blows up if you want to. This is pretty much on your device, and it allows you to use all these AI capabilities without getting any cost per query, without having to set up tokens. We will talk a little bit about that, about the token limitations that exist. but those are specifically from a resourcing and processing perspective, not a cost perspective. The next thing here is that server-side AI is still a thing, and it definitely still matters. So we're not trying to replace server-side with our client-side model. That's not the goal here. The fact is, we're trying to offload some of the things that you might require server-side to do onto the user's device. And then when you want more powerful capabilities, for example, if you wanted to generate an image using AI, that's when you would call a server-side model. But if you wanted to do something like tell me what this image looks like, what's in this picture, that's something that we think is really good for a client-side model. And that's what we're hoping to aim for here. And in terms of how they can play together, you can actually put them in the same code and allow your client-side model to try and take a first stab at what you're doing. If it doesn't do a great job or if it fails, you can always have server-side just sitting there in the background as a backup. And so you capture that event, handle the failure in some gracious way, and then ask your app to ping the backend server to perform the same exact task. So you really do have a lot of flexibility in your choices, and that's what we want to give you, the opportunity to pick what works best for your app and what works best for your users. Now, as we mentioned, this AI thing is a very vast spectrum. And when we say lightweight versus massive, this paints a little bit of the picture of what we're talking about. So the massive models are your typical LLMs, your Geminis, your ChatGPTs, your Claudes. They're trained on a huge amount of data, and you need data centers in order to process those things. In the middle is where you start to see some overlap between the two in terms of like what are some of the tasks and capabilities that an LLM could perform that we might want to offload to a lightweight model. And then the way we do this is essentially create these lightweight models that are very hyper optimized for one specific task and let it get really, really good at that. And then package it down super small such that folks are able to use that locally loud. Now, super small is definitely a relative term. Like these lightweight models are still like 4 gigs, but that's a lot smaller than the like hundreds of gigs it would take in order to use some of the bigger ones. I'm going to skip that slide. So the next thing that we're really focused on here is actually earlier this year, we started experimenting with some of the multimodal capabilities to try and expand the usage of these smaller models. Typically, what you normally see is a text to text, which is like I give it a prompt, it gives me some response in text back. What we're trying to do now is can we start to take advantage of the fact that like the world is not just text, like there is a rich set of media that often comes in the form of images, videos, audio. And so what can we do in order to supplement those use cases while still maintaining the small and like compact size of the model? And as I mentioned before, you can absolutely do client-side and server-side implementations in the same web app. And we often encourage that. Again, there are some things that the lightweight models are not going to be able to do. That's just a fact of the matter. And there are some things that the bigger models, they're just going to take more time to do because they're bigger. And so how do you find that sweet spot and like where they can play together? That often depends on the use cases that you have. But this is some of the things that you can consider now as you're building out your web app. And so when we say hybrid AI, this is exactly what we're referring to is what are the things that server side and client side can play together in your development. And these are some of the considerations that you can make. For instance, if your client side model has enough data from the web page that you're looking at, then let it run the inference and task for whatever needs to be achieved on that page. Whereas if you have something that's really complicated, requires multiple inputs, might need some additional processing, this is where server side starts to come in handy. And the flip side, when we're talking about capabilities, client side is great when it's really you're working on a great new laptop. You might have pretty bad internet, or you're just somewhere where like you would love to be able to use AI, but it's just not sufficient for that. Whereas on the flip side, if a server side model could handle some of that offloading, maybe it's better for your lower end devices, but it needs the internet in order to be enabled. And so that's where you get to see some of the trade-offs and like where certain things could be better in different use cases. Last point here, and then I'm gonna jump into actually teaching you guys some of the code and like what we can do to dive in here and actually make this a bit interactive. And then I'll show you a couple web apps that I've built using some of the multimodal features so you can see what is actually happening in the website with Gemini sort of nested in the background. So before I jump to that, last thing I want to mention here is that you can use Firebase, which is another way for us to integrate both your Gemini Nano on your client side and Gemini on your server side. And they play very nicely together because it was built out of the box to do so. So thank you. We love to see that. If you are a Firebase user, this is actually something that might be extremely helpful to you in order to sort of offset some of those costs that you get when you're calling the Gemini developer API or Vertex and pull some of that over onto the client side. So let's jump into this and I'm going to show you guys what exactly is available and then how we can actually make some use of it. So right now, there are, I want to say, 7 APIs that are available. I would say you could technically break some of these out into their own thing, but uh, for brevity and just because I feel like they could be grouped that way, I grouped a couple of them. The ones that you can find in Chrome right now, these are fully launched. You don't need to do anything special in order to use them. That's prompt for your extensions, the summarizer model, and then the translator and language detector. We'll get into the details of how these actually implemented and like what are some of the nuances you need to look out for when implementing them. But I'll get to that later in the presentation. As far as the experimental ones, we have the image and audio, the multimodal APIs that I just mentioned before, the writer and rewriter, and then the prompt API, which is essentially your standard LLM, but in a much smaller model. And this is actually also how you enable the image and audio. So I I know image and audio is duplicated here, but I wanted to make it clear that like those two particular APIs are actually not their own thing. They're just nested within the prompt API as acceptable inputs. And for the prompt for extensions version, you essentially don't get those. The prompt in your web app, you would be able to enable those. We'll blaze quickly through this slide. This one is probably something that will be useful for you as you follow up and review them. But the most important call out from this is, again, that storage and size aspect. Each task model is essentially 4 gigs each. And so you do need to be mindful of that. If you download every single one, you'll probably take up quite a bit of space. And so we recommend that you have about 22 gigs of free hard drive space. But that depends on the use cases. It depends on how often you guys are using this. I'm going to pause for a second because I want to check out this comment. I do want to text the experimental hashtag, but don't want to miss. Oh yeah. We'll get to it. Don't. I'll show you it, and then we can come back to it later. Don't worry.
And just if you do happen to need to restart your browser and jump back in, we don't advise it, right? But you should be able to come straight in. I've made it so that you can. I don't have to admit you back into the call. So feel if you do get out, you should be able to get right back in quick.
Awesome. Thank you for streamlining that. That is helpful. Not too much more to speak on this side. You can see some of the OS requirements and as far as network goes, I did mention that these are available offline, but there is a caveat to that. The very first time you use the model, you do need internet connection because the model needs to download its dependencies, like they're not already there. After that, anytime you decide to use the model, it will already have its dependencies. And so if you turned your internet off, you could still keep using AI features on your web app. And last thing to mention here is that within that translator and language detector API, you're going to need a little bit extra space, not too much. As you can see, it's only 70 to 100 megs for a language pack. But if you want to do a translation, let's say, for example, between English and Spanish, you're going to need the Spanish language pack so that it can actually do the translation for you. But for, I mean, the additional megabytes of storage in comparison to the actual gigabytes that the model is taking shouldn't be too much of an issue. But if it is, that is something to consider. And as you just mentioned, these are the flags that you can go ahead and enable. I'll send these slides out to you afterwards, so you'll have these exact screenshots in order to be able to follow along how to do this. It's really just going to this link, Chrome://flags, and then enabling these various APIs to do what you need. I will make one call out here. The other way you could do this, these are enabling it locally for your computer for any local testing. For your site, if you want to, let's say you built something really great, you like it locally, you want this available to your web app going forward, what you would want to do is register for something called an origin trial token. And essentially what you're doing is registering your web domain. So anytime someone comes to your site through Chrome, Chrome gets a little header token from the server that says, enable these features for me when this user comes here. And so essentially this happens automatically for you if you implement that token. And once things move from origin trial or experimental into stable, you won't need the token anymore. Even if it's there, Chrome will just know to ignore it. So there's no like thing that you have to remember to do to break it down after you're working with it. This is simply for early experimentation purposes. Cool. Let's jump into the code a little bit. So this is a very simple implementation of what you can do. As you can see, this is purely JavaScript, like super simple. You could write this right into your browser right now, and assuming the flag is on, it would work. Some of the things to call out as just basic pieces of how these APIs work in general. You're typically going to have a .create step, which is how you instantiate the object for your AI model. And oftentimes it's going to come with some various parameters that you can give it in order to help it out. I will give you some more context there later and show you in the apps that I've built. For this translator one, you can see like some of the parameters you need are what am I translating from? What am I translating to? When you call this object, you are literally calling the verb for whatever that thing does. So translator is going to be .translate, summarizer is going to be .summarize, and you're giving it the input to the function that you want it to do a thing for. And then lastly, you'll see in the part .translate streaming, this is where you'll get the output from the model to say, this is all the things that it understood about the input that I was given and what the output should be. Now, all of these APIs follow a very similar shape and act in almost the same exact way. So some of the things that you'll want to do, like checking whether the model is available for a specific user, that is the same exact call. If you want to accept optional parameters, create using that .create call or .abort, .destroy, they all look exactly the same. All you're doing is calling it on the object that you instantiated. And then for something like a minimal change that you would see here, for instance, between the prompt API and the summarizer, you might say .prompt streaming versus .summarize streaming. So you can see there's a very like specific pattern that it's following. The only thing that's different is the name of the API that you are operating on. Now, in order to, again, as I mentioned before, get this thing working, you're going to have to do an initial download of the model's dependencies. And so when you call .create, that's essentially what's happening. And if you wanted to keep some kind of progress bar or like notion of how long this download is taking and where the user is at, we do make that available to you through an event listener. And so you can actually follow along with, is this model ready or not? Can the user use it? One call out to make actually is that these models, you can't automatically download them when you get to a web app, and it's for privacy and security reasons. they don't want to. We haven't designed it in a way such that like AI can just start doing whatever it wants as soon as you load a web app. Like the user needs to have some notion that this AI is there, that it's doing something, that you need it for these purposes. And so typically you want to put like dot create call behind some sort of modal or a button to say like download this for me when I get here. Or if it's behind the actual function, like you click uh summarize this text for me. That click from the user essentially enables the browser to go ahead and start downloading the model to do what it needs to do. So it's just one quick call out to make there because I know a lot of people have run into that issue and it's really important and people often don't understand why. So that's the reason why. Next part that I want to get into here, I think this is more so for people who like want to get into the nitty gritty of this, which is you can play around with the way the model responds in terms of like what basically the way that I think about this is temperature is like how much of a variation do you want in the response that it creates. If you give it a really high temperature, then it can start hallucinating, but like that's what you would ask for. Um, if you gave it a bigger top K is essentially like the probability of the next thing that it generates based off of its understanding of what you might be asking for. So that part is kind of complicated. Typically suggest like you just leave them the way they are. Their default values are kind of in the position where we think they're good enough to handle whatever you throw at it. But if you wanted to get real fancy and like start playing around with what this thing could really do as a smaller model, that's when you can start messing around with top K and temperature values. Next call out that I'd like to mention here is your context window, which I think is probably really important for most people to know. As you know, if you've played around with any other LLMs, you only have a specific amount of tokens that you can use. And typically for a bigger model has a lot of tokens that it can consume in one sitting in order to draw some inference or response. In this case, there's no limit to the number of tokens that this model can consume, but there is a limit to the number of tokens that it can ingest for one call. That limit is 9,000 tokens, and you'll typically want to be mindful of how big of a context you're giving it. It's gotten a lot better over time. It started off with, I think, a third of this window, and over the course of a year, we've gotten it much higher. So shout out to the Eng team for that one. And I think this is something to be mindful of. There's a couple things you can do here in order to keep track of that if you need to. And lastly, I'll mention that there's an error that will fire if you go over 9,000 tokens. So let's say you hit 9,001, you'll get a quota exceeded error. You can capture that from your JavaScript and handle it gracefully to tell the user like, hey, what you gave me was too big, take out some of this stuff, or you can opt to try and massage it yourself such that it doesn't exceed, but I wouldn't recommend that. But yeah, there are ways that you can kind of gracefully handle any issues that might pop up as a result of this.
Hey, I have a quick question on that.
Sure.
9,000 seems pretty small, especially, Gemini's, million token, and, all the other ones are in the 100, 140, 150,000, 200,000 range. So what would 9,000 roughly look like? I know as you've been testing it here, just kind of give us in layman's terms, what you feel like that, or maybe this kind of talks about it here.
So I guess to answer your specific question, I would say 9,000 tokens. I haven't pushed the exact limit of it, but I can say I can give it like 3, 4 paragraphs worth of text, and it
Okay.
is able to handle it without any issues. It would blow up if you tried to give it an entire like Google Doc, or if you told it like read me this whole web page. Like it probably can't do that. What it can do is read the HTML of said web page. And so if you said look at this specific aspect of my HTML, can you tell me et cetera, whatever you need to know about it. It can definitely do that. And I think that's one of the strengths of this is like it actually has the context available to it because it's just JavaScript. So it can also access the DOM and you can give it whatever specific context you're looking for.
Mhm.
And you just need to be prescriptive about that thing you're giving it. Like rather than like, hey, consume this whole DOM object. Like maybe you want to say document get ID, like just this form, and then do something with that rather than trying to give it all the context in the
Right,
world.
everything. Okay, thanks.
Mhm. This is just a quick diagram to illustrate what I mentioned about this overflow. And so on the right, you'll see if you give it more than 9,000 tokens in one go, it's going to blow it up. On the left, it's still monitoring the tokens that you give it, but when you give it in smaller chunks, you also have more discretion to play with. You can tell it like uh once it overflows on that third prompt, like get rid of the first prompt and make space for the third one and then keep doing what you're doing. So it's not as what's the right word here? Like detrimental. It's not going to be destructive if you give it in smaller chunks because you can manage it. If you give it one big chunk, that's where you start to run into problems. So I would just be mindful of that as you're developing. This one we can go over quickly. You saw me use this in the earlier slides as well. Streaming essentially is like the way you interact with a normal LLM. You give it a thing, it's giving you text in like small chunks, and eventually it parses out the whole thing. If you just said, for instance, in this case, like dot prompt, it's going to do the whole thing, and then it's going to give you the entire response in one big block. I think people typically prefer the streaming approach just because you can see and know that it's doing something. So I would recommend for most of the APIs that that is the approach you take. But if you wanted to flip between the two, this is how you could do that. This part I think is also super handy for folks who are very technical as well, where you have structured output and you can play around with the way that it responds to you in your JavaScript. And so you can create custom JSON objects and then tell the API, put my response in this JSON format, and then I want to do something with it. And I'll actually show you, I use this in the example that's coming up here. As a way to interact with a form that's on the page. Go through this one quickly. These are all the languages that are supported by the Translate API. The main thing you need to know is on the right side. For each of those languages, there's a two-letter language code. That's what you want to give the API in order to specify said language. And just remember from before, each of these language packs is about 70 to 100 megs. So I wouldn't recommend using every single one. I would just pick the ones that are most relevant to the use case that you have. And lastly here, I'm about to go demo this, but these are how you do the multimodal inputs. Essentially, you're creating just a typical prompt session, but you're telling it that you're either going to give it audio or an image as input. And then when you capture whatever multimedia set that you have in the JavaScript, you create that, you assign that to an object, you pass it along as a value within the prompt, and it will be able to do some pretty neat stuff. Like I said, I'll show you in a second here what I got for you. In the interest of time, I'm going to skip over this part. We're about to go into what you can build with this right now. But when we send out the slides, feel free to go through these use cases and see what exactly might fit for the web apps that you currently have. So I want to switch over to a couple things that I built and show you guys what this can do. So hello again. So what I did here is I took the multimodal API, the image detector. What I did was basically create a Pictionary game here. So AI is going to tell me, or rather the app is going to tell me what to draw. AI is going to try to guess what I drew, and then in 2 minutes here, we're going to see how good or bad of a doodler I am. I think I'm pretty good. AI might disagree with me, so feel free to join me for this ride, and hopefully I can get like 3 points. So let's rock here. Oh, I didn't plan that. The first one wasn't supposed to be a rock, but I hope that my interpretation of a rock is something similar. And if not, at least it might be able to understand something else that I drew. So maybe this is a mountain. Who knows? We'll let it rock. That is definitely a triangle. I'll give it that. I don't know how to draw a valley either. I probably should have picked some easier words and just let it like do what it does. This is my interpretation of a valley. Don't laugh.
That's a hard one.
I'm just gonna skip this one because I can't draw an elephant without some sort of trace here. But I am a person, so good guess. All right, banana, I got this one. I definitely got this. I can draw a banana. I used to doodle in grade school, so like hopefully I can salvage this one, right?
Quick, 75 seconds.
This looks like a banana to me.
That's
Like
good.
there we go,
Yes.
one baby. Cookie. I think I can do this too. It depends on if it
Gotta be
thinks
chocolate chip.
chocolate chips or just uh what's that? What's that
That's
fear
the
of like
moon.
seeing
Sphere.
sphere. Same difference, I suppose. Tree. Okay, I think I can get this one, and I'm running out of time, so let's just go for a Christmas tree. Hopefully it gets this one. Also triangle. Okay. I mean, someone's gonna come in this room after me and be like, "What is this dude doing, bro?" Like, I thought I was pretty good at this, but I guess not. I'm getting humbled today, and that's fine. That's fine. I was here to present to you guys, not get an art degree. So it is what it is. This is probably a okay. I'll take it. I thought it was a cart, but
Good job.
now this water could be interpreted in many ways. Waves. Actually, I'm not gonna disagree with AI on that one. I think it looked more like waves too.
Well, I'm curious. It's saying necklace. Can you point to what's on your neck?
Uh, it's gonna take my entire face and be like,
Oh,
yeah, that's definitely you're still a person. Like you can't confuse me. But I think it's a pretty good necklace. Okay.
oh,
Well, I'm
hey,
gonna count that as a point. And you all saw the necklace. I think I did. I'm gonna say that that counted.
I love
Okay.
how the prompt is necklace and your guess was necklace.
Yeah, I don't know why it decided it wanted to randomly put a dot here and mess up my string matching. But y'all saw the picture. Like that was a necklace. So anyway, I'm gonna show you another web app that I built here, but before we jump to that one, so basically it's exactly what it sounded like, where as it's giving me guesses from the web app, the AI is interpreting what's in this square and trying to match it to a word. And I did this by like literally telling it, as you guess, like give me the best one word description that you can think of for what you see on the screen here. And so it captures a screenshot, it sends that over to the prompt or as input within the prompt, and then it tries to guess, all right, what's the best one word descriptor for whatever this thing was in the screenshot. um, yeah, I think that the other thing to call out here is everything was running locally from my laptop. So it wasn't calling any server. I didn't use any tokens on my like Gemini account or anything. It did all of that right here. And as you can see, even with 9,000 tokens, like it's got a lot of context for what you can do. Like if you gave it that image, you could probably still give it like 3 or 4 more paragraphs of information and it would still very much be able to sort it out.
Could you expose any sort of like token counter?
Not in this one, although that would have been really good for the purpose of the example, just to show on the bottom what that's actually doing. Uh yes and no. For all intents and purposes, this is Gemini Nano, which is technically different than Gemma. but I will just leave it at that for the moment. Like this, we consider Gemini Nano. Okay. Next thing that I want to show you. So I built a fake little web app for I call it the Body Shop. It was supposed to be a play on Body Shop, but it's for watercraft, so it's the Body Shop. And so one of the things that I did with this, which also was completely vibe coded, like Gemini CLI, shout out to that. It did a great job and pretty easy to get a pretty simple website up and running. Um, what I implemented with Gemini Nano for this, though, was in the checkouts. And so I'm just going to skip right to that in the interest of time to show you what Gemini Nano can help you with in a more probably real world use case. Now, this probably would have been helpful like 10 years ago before autocomplete was on everything. So, like, take this example with a grain of salt. It's super easy this point to just like click. The browser already knows all this. I can just autofill it. But what I did and what I wanted to play around with was, can I just tell the browser what I want to put in these fields, and would it be able to parse it out for me? And so that's what we're going to test out real quick. Um, Another live demo is still like praying Gemini Nano doesn't make a fool of me, but this is the audio to text API implementation. So my name is D Brown. My address is 123 Broadway. My city is New York. My state is New York, and my zip code is 11201. I don't think I got the zip code off in time, so it probably chopped it off. But okay, let me show you some other stuff because y'all could think I just pre-programmed it to do that, right? So
That's amazing. Yeah.
so my card number is 1234 1234. The expiration date is 0829, and the zip code is 11120. Dang, I can't get the zip code fast enough. But okay, and then you can also do stuff like, can you actually just move cities? The city is Philadelphia, the state is PA, and my address is 123 Main Street. And let's see if it can parse it out for me. It missed the Main Street, but it got the rest. So we'll give it some props for that. And so what this one is doing is I enable the camera, or sorry, not the camera in this case, the microphone. It's ingesting everything that I'm saying. But what I did was actually take advantage of that JSON schema that I showed you before, where I told it, like, here's the JSON schema for this form, and here's all the keys that you need to fill in. So when you dissect this audio file, I want you to be able to match what the user said to the key that it belongs to. Keep that in a variable, and then at the end of this, the variables just autofill. If it's there, I put it. If it's not, it just ignores it and it keeps on moving. And for the most part, um, I mean, there's a lot of ways that you could definitely make this better. Like, I didn't put any validation in this, so I could have told it that the city was blue and it would have put it there. But that is something that is like at that point really just feels like standard JavaScript. The main aspect of it was using AI to get my voice and information onto this page. So those are the two examples that I wanted to show you. I know we got 15 minutes left here, so I want to leave some time for questions. But I'll flip back to the presentation real quick just to show you that we do have, oops, this is the wrong one. Share this tab. We do have a repo of a bunch of other examples that you can play around with. The two that you just saw are mine, but I'll throw them on GitHub so you can go play around with it if you like. And the documentation, the origin file registration, all that good stuff is at this link. And if you are like a developer who like really wants to get into the nitty gritty of like the top K, the temperature, all that stuff, there is GitHub documentation that I can send you this afterwards to like really start to dive into the meat of this. But with that, that is my presentation for you guys. So I hope you all enjoyed.
That's awesome. That last demo there was amazing with the filling out the address. And I saw there was a couple of questions there, and a lot of folks seeing the accessibility prospects on it. You know, the one I about audio to text being a token gobbler. Again, any thoughts on what the consumption of tokens would be with the audio?
Yeah, that's a good point. Again, I have to measure it, but like from what I can tell, it hasn't had any issues with that, right? Like it's all it's doing is getting a 10-second audio clip here. So the file itself is not that big, and it still has more than enough space and inference to understand that, along with the system prompt that I gave it to tell it, hey, like do all these things when you see, or rather when you hear in the audio clip, the name, the address, the city, the state. Actually, maybe I can let me find this for you real quick. I can pop in what the system prompt that I gave it was. And I think the beauty of it is like it doesn't even really need to be that complicated. You can use a pretty small system prompt and just let the AI take even bigger audio files if you want to. Um, and I didn't have any problems with it. So give me 1 second. Let me. I'm just digging through my code to find this line. So this is what I told it. And as you can see here, like this was, it used a bunch of tokens for this part, and then it took the audio clip, and I can't imagine that was more than like 2,000, 2,500 tokens tops. And you can always clear it to free up more space if you need to. So token management is something that's a little tricky, but it's not. I would say it was much more of a problem when we first started this, and it was like 3,000 tokens or 6,000 even. But 9,000, we're actually starting to push like, all right, there's enough space to do some pretty snazzy stuff without running into hiccups or like it tripping over itself to get it done.
Do you have a sense of what that, I don't want to say the theoretical limit would be, but at least, you know, given this, the scaling that you've been seeing, where do you see it landing in, let's say, the next 3 to 6 months?
That's a good question. I actually don't have the answer to that. I can follow up with you guys and let you know though, but I feel like two of the things that are definitely top of mind for this team as we continue to develop this out is A, making it available to machines that aren't on the newest, latest, and greatest hardware. Like, not everybody is going to have an M3 or M3 chip for their MacBook, or like the latest OS or whatever. So, or even like GPU and like an extra RAM to for it to consume to do this stuff. And so one of the parts of optimization that we're really focused on is like, how do we make this better for legacy and older devices? And then the second part is what you mentioned, like how do we continue to expand the context window? Where does it cap out? I could not tell you, but I know that is something that like we're making incremental strides on and like continuing to try and push the envelope of how much we can really get in there while still maintaining that like 4 gig size for each of these task models.
And I see Debbie's question in chat there around the system prompt being counted. So I believe you had a slide that showed that, right? So the system prompt is part of that 9,000.
Yes. Let me see if I can find that. This one. Yeah. So your system and your initial prompt do count towards the total limit. And as you can see, these slides are a little old too, because I only have the 6K limit on here from before. As I mentioned, it's 9K right now. So you have a lot more space to deal with in that regard. Any more questions?
Yeah, and as that's come through, I'm curious, what about degradation? So if the, you know, someone comes in and that their machine can't support, or is there any thought towards like UX for that? Like, how would you get an indication that this is either available or unavailable to the user?
So that's in order to start the process of doing this, that's like quite literally the first call you have to make is dot availability. And it's going to return like one of 4 values, either It's available, but it's not downloaded. I think that one is downloadable. Unavailable, which means like this hardware is not sufficient enough to support this device or to support this feature. Um, or it's already downloaded. Like you don't need to ask this question, just go do what you're doing.
Mhm.
And I think there's one more, but it's like escaping me right now. But those are the three main ones.
Gotcha.
And you just said something too. Can you repeat that question for me? There was one more thing I
Well,
wanted to.
well, just think about like graceful degradation. So as it's like, hey, this isn't working, or maybe there was an error there. Whether there's kind of built in like prompting or toast messaging around it.
Yeah, this is a good one. I've actually been discussing this on my own. Like, I think this is something that the API could do better, is give not just developers but users a better indication of like the state of the model. And it's not built into Chrome right now. Everything would have to be handled by the developer. And so you'd have to do something to the effect of like, if availability is not yes, any one of the other things like produce this toast message, this window alert, whatever UI element of your choice is to say uh, why the user can't do this or what they can't do. I think a better and more graceful way to handle it would actually be this is where the server side starts to play a role, where you can say if this is not available to the user, then rather than telling them anything, because they really shouldn't have to manage models on their own, uh, now we pull in our server side model to complete this particular task or run. And it goes back to that slide that I mentioned before, where like these are your trade-offs. This is where it's like, if you're on a poor connection, how can we take advantage of client side? But if you're on worse hardware, then how can we take advantage of server side? And that's where you want to, like, as a developer, think through your use case and build accordingly. We got another question here. Sorry if this was already asked and answered, but is there anything on the roadmap for session management? For example, if a user refreshes the page, the existing session no longer exists. But does that get cleaned up via garbage collection? And should we use local storage to pick up where the user has left off? So I need to double check this. I actually believe that the session should still be available because it's tied to your browser, not the web page. And so, in theory, like if you reloaded the session, you would lose any context that you got from the user, but any system prompts or anything that you use to kick it off would still be there. And in terms of management, you actually do have a few things to play around with. There's one slide that I didn't include here. There's a method called .clone. .clone essentially lets you save the state of your uh, AI session as you're getting more stuff. And each session has its own context window. So if I said like prompt dot create 3 times, now you're consuming a ton of local resources to do this. So again, trade-offs. But like it created 3 different instances of AI that all have their own separate context. And I don't know why you would want to do this, but like that is it's just to illustrate really that like uh they're kind of operating in their own lane, and you can choose to clone and save those sessions as you like. You also have .abort and .destroy methods that allow you to manage whether you want to keep those things available to you or not. The only time I've really seen that you need to do that is if you like you plan on doing multiple things within the session, such that you need to start destroying things in order to free up space. But I haven't run into that issue doing any like local development or playing around with it so far.
What about mobile? Any ideas on when it might be available, or if at all, for mobile?
Mobile's a tricky one. Mobile is even more problematic than desktop because now you need to condense 4 gigs again into something even smaller that a mobile device can handle. And so I think that's something that long term we would be looking for, but that wouldn't be for years down the road. Like I think they're trying to optimize for desktop first, and then once we have a good basis, Mobile will definitely be next. I will say that one thing that's quite interesting is actually with the translator API. The one that we're using is actually a pre-trained model, the same that is used by Google Translate. And so, in theory, if you actually wanted to test any of the inputs and outputs that you get from built-in using the translator, you could go into Google Translate on like an Android, turn off the Wi-Fi, and then just start playing with it. And the model that sits behind Google Translate in the app is also the same exact model that this is using for its translation capabilities. So I know it's possible, and I know even getting that Translate app or Translate model to work for the Translate app was like a lot of work. I think doing that for all of these is definitely going to take some time, but it is possible and is something that the team is looking at.
Great. And I know we're coming close on time here. In terms of, for a lot of the folks on the call, and myself included, I definitely want to jump in and play around with it. And we shared, I put it into chat as well as we're going to share off the deck here after the call. With the playground stuff, how much time would you say from when just kind of rolling up the sleeves and say, hey, I want to do this to getting something functioning, would you say someone should estimate?
If you have an existing web app already, this will take you like less than an hour, like probably 30 minutes. The calls are like quite simple to get set up. In fact, the one that I gave at the beginning of this presentation here, again, you could pop this into your web app, it would work, as assuming the flag for it is enabled and it works on your domain. This is all the code you need in order to get it started. Where the like nuance starts to come in is like, how does it fit for what you want to do? And again, this, as you play with it and start to understand the way that it operates, you could get something really nice done in about an hour. And I would say I built my web apps from scratch. So it took me a little bit more time because I wanted to play with the layouts and get everything like presentable and somewhat realistic looking. But that took far more time than it did to implement the built-in features.
Awesome. Okay. All right. Any other questions? Great. Well, thank you so much. Really appreciate it. So we will share the video from this in an email follow-up with everyone, and really looking forward to it. And Damani, thank you so much for your time and walking us through all this today.
Of course, happy to help. And if there's any questions, like feel free to reach out to me on LinkedIn. Happy to connect with you guys, walk you through anything that might be helpful, send you more documentation. And please also give us feedback. Like if stuff sucks, like I want to know. I think this is how we make things better. So don't be shy.
Perfect. Hey, thank you so much. Really appreciate it. And thank you everyone for joining.
Thank you, Damani. Thank you, everyone. Take care.
Thank you. Bye,
Take care.
guys.